Before we get started, to help us better answer your questions and give some better commentary, I'd like to do a quick survey. How many people in here are CLDs? How many people are CLAs? Okay, I'm assuming most of the other people don't have any certifications, which is totally okay and fine. Let's see, how many people manage a team or work in a team? How about that? For which everybody works in a team. Okay, so no solo developers out there. I will say I do a lot of solo development, and everything we're going to talk about today does apply to solo developers too. So if any of you guys didn't raise your hands and you're solo developers, it is applicable still. What other questions? How many people are doing what they would call continuous integration? Okay. How many people want to do continuous integration? Probably why you're all here. Right? Great. How many people are doing unit testing? How many people do automated builds? Whether it's CI or just like, you have a VI that you press a button instead of just right-clicking on the build spec and clicking build. How many people are doing things like VI Analyzer and using it regularly? How many people run any of those things from the command line? Okay, well, as you learn, that is one of the first steps. So you're going to have to figure that one out, and hopefully we'll help you with that.
Sam, I'm interested in if people are using source code control and what kind, where they host it.
Okay, yeah, I was kind of hoping that was a given, but we'll ask that question. How many people are using source code?
Control.
If you're not, I won't force you to raise your hand, but that looks like everybody. How many people are using SVN? Okay. How many people are using Git? Okay. Let's see. For those of you who use Git, how many people are using GitHub? GitLab? Azure DevOps? Something else? Anybody using something else? Bitbucket. Yeah, sorry, I forgot you're a Bitbucket guy. Did that answer all your?
Yeah, thanks.
Okay, great. So we'll do quick introductions. James did some introductions. My name is Sam Taggart. I run a small consultancy, mostly single developer. Sometimes I have some contractors I bring on. Sometimes I work in small teams. I used to work at a company where we had a larger team, and so I've got some experience with that as well.
Hi, Chris Roebuck, software architect at Konrad. For those who haven't yet used VI Analyzer, because I noticed there were some hands kept low in the room, take a look. I've got a couple of presentations on why you should be using it, so seek those out. I work with our customers at Konrad on improving their processes, so helping them use source code control as a team better and implement some of these things that we're going to be talking about today.
I think I'm mic'd.
Oh, okay.
Can you hear me okay?
Yeah.
Great. My name is Jim Kring. I work at JKI with some other fellows here in the bright green shirts. I left mine at home. I've been involved in continuous integration and LabVIEW for a very long time at JKI, and we work on a lot of different tools, the package manager, Pariah, VI tester, and other tools. And I think for the longest time, we've all believed that LabVIEW is a real software development language and platform. And so we need to be able to do the things that real software developers can do, such as automated builds, command line builds, package management, et cetera. And so at JKI, we use continuous integration all over the place, ideally for every project. And even though this is entitled Don't Leave Home Without It, typically this is running in the cloud often, either at your company or on servers hosted by GitLab, Bitbucket, et cetera.
Or if you're like me and you have a server sitting in your basement, it literally is at home.
Or you can do that, but you don't have to be stuck next to your computer, kicking the tires on it to keep it working. So that's one of the nice benefits, is that it can be running tests. You can schedule it to run tests nightly on a big code build, do different FPGA builds that take hours, and save a lot of time. So then you can leave home and go do other things that are fun instead of watching you build.
Yeah.
Hi everybody, my name is Jorg. I'm joining from Germany today, thanks to the wonders of technology. My professional interest lies in software development in teams. I find that very intriguing, both the technical and the human side of things. I run my own small company, and we've also been invested in the automation of processes for quite a long time. Beginning with making life easier for myself when I had to deliver software to our customers, and later on when the whole CI/CD thing became more popular. Yeah, we started looking into how to leverage these technologies and how to make our lives easier. Also how to make teamwork easier. Again, that's where our focus lies. Running tests automatically, creating documentation automatically, building and deploying software automatically. These are things where we can have quality improvements, we can have savings in terms of time and resources. Of course, also at a cost. And yeah, I'm quite happy to be here and to hear lots of questions and opinions on the topic.
Great, thank you, Jorg. So the first thing I think we should talk about, and obviously you guys are here, so you see some value in CI/CD, but I think we should talk about what the value is. What do you get out of doing it? And then we'll get into the mechanics of how you do it and how you get started and all those things. The little description in the app mentions ROI, and I think that's a very horrible term to talk about CI/CD. It's like asking what's the ROI on your insurance policy. It doesn't make a lot of sense. I view CI/CD as a risk management tool. So you're managing the risk of introducing bugs because your CI part of the CI/CD pipeline should be running tests and making sure it builds and catching things before they get to your customer. And then the CD part is about making sure you built the right thing and there weren't miscommunications in the requirements, because every time you add a new feature, you can push it to your customers and they can go check it and test it and make sure that it's exactly what they wanted. So to me, it's all about managing risk, but I'm interested to hear what other people have to say. I guess we'll go to Chris first.
Okay, so yeah, pretty much everything that Sam said, but also the time aspect. We've all sat there with large applications, kicked off a build, and then thought, right, I'll go make a coffee. I've context switched into having a chat at the water cooler, or having a coffee, doing something else. That's kind of dead time. With these processes and tools that we're talking about, that action of carrying out your build, running your unit tests, running your VI analyzer tests, is performed asynchronously. So we can kick off that build and then go do some other useful task.
Yeah, so we talked about risk, we talked about time savings, and then I think another aspect of it is automating steps in a software lifecycle that a human, even if they're simple steps, might get slightly wrong. And so, Sam was mentioning for CD, continuous delivery, the value of having your customers telling you right away if there's problems. One of the problems that can happen in delivery is, if you're uploading files for download, maybe updating your website with the link, that could be done incorrectly, which then causes, problems in your delivery chain. So one tool that a lot of the CI/CD platforms offer is ways to manage like uploading files to a server, SFTP, like S3 storage of files. You can update other meta information, like in a check for updates file. So literally, it's possible to check your code in to source code control. Even do a special tag, push a tag on a Git commit and say, this is a release version because it passed all the tests. And you can even verify that the tests are passed, and it'll fail the deployment. If they fail, it'll upload it, modify the update index file of the latest version, and your users will see a check for updates available. Literally, a developer working on their computer could do that. And so there's so many steps in there that are hard, remembering the keys to access the site, to get files uploaded. So it's really amazing over a period of time that you're managing a software product. Those steps that you do rarely, even if they're simple, will be hard to get right.
I think that goes to the fact that basically we're doing what we do every day, right? For our customers, we sell them on automation as it being repeatable, right? And auditable and all these things and all those benefits. We're just doing that for ourselves, for our own code. Jorg?
Yeah, I want to add that, again, the team aspect is quite important for us and for our customers. Usually, if you want to automate something, you better look into that something before you automate it, because if you automate that process, things get worse, actually. So in order to make a team work together nicely, flawlessly, with as little friction as possible, of course, you need to have workflows, you need to have processes, and some of those can automate, but also some of those become better defined and clearer because you want to automate them. So if you're thinking about when to run the BI and run the tests, if there is no automation system, no CI/CD system, there might be discussions about that. If you do have pipelines set up, you can say whenever you close your feature patch, whenever you open a release patch, for every commit, whatever it is. So you can dictate the cadence of the actions by defining a workflow that ties into and augments your CI/CD process. So everything the guys said, and that bringing that together in a team situation, I think CI/CD can help a lot with that.
Yeah, thank you, Jorg. Those are all good.
Where do we start?
I'd
Yeah.
be curious to find out. I'm curious to find out what problems or challenges the audience has. So where are some of you feeling either like stuck or even curious about like how to get to the next level in this continuous integration, continuous delivery process?
If you raise your hand, I'll bring a mic to you.
Yeah, I think along those lines, how many people have tried and maybe been not successful?
Hi, Evan Brady, Lockheed Martin. So the issue I've had most with LabVIEW continuous integration is like having enough runners, because like LabVIEW doesn't play as well with Docker unlike other programming languages. So I guess like the infrastructure there for like N+1 runners. So I'm curious to see what you guys have done for like having like a large team with many runners.
So in-house, we have a service that can detect build processes spinning up that utilize a certain container and that can spawn an instance for that specific job. Doing that, however, there's a lot of different tools that have to be kind of brought together to do something like that. And there are services, I think, that do things like that. One of the challenges with LabVIEW, as you said, it really requires a lot of the Windows core infrastructure to be able to work properly. So it's still a bit of a challenge.
Yeah, I don't know. I can give the perspective of like a smaller team. I mean, basically, I just use virtual machines, and I have not gotten to the container part where I spin them up. So if I had needed more, I would just have to spin up more and start them myself and always have them running. So probably not the ideal solution. But anybody who's listening, if you don't work on a big team, don't worry about that problem yet. That's a problem I would probably encounter, or that's a bridge I would cross once you get there, right? So.
Sir in the green shirt.
You usually can't learn, if you just want to do LabVIEW CI, LabVIEW can't do it by itself. You usually are going to have to learn some YAML or some PowerShell or some bash scripts to kind of stitch it all together. How do you get over that learning curve so that you can just write LabVIEW and not have to write all the interconnected pieces?
I would say take advantage of some of the stuff that's out there. So I've been putting together some tools, and I have it's SAS-GCLI tools.gitlab.io or something like that. And it has some information and some tools there. Yeah.
So James McNally in the UK has created a really great tool called GCLI. And it does a great job of allowing you from a command line to run LabVIEW code. Typically, this is done running code in the LabVIEW development environment, like starting a build. And you can pass command line arguments, and then the code that's running in the LabVIEW IDE can use a reference to the connection from the command line, and it can send back status updates And so a lot of people have used that great library as kind of a building block for their own custom build.
To Jim's point, if you use that, you don't necessarily need to know as much scripting because you can do a lot of the stuff in the LabVIEW code as opposed to doing it in the scripting code. You do still have to learn some of the YAML stuff to set it up. But Jorg, I don't want to forget about you because you're like over my shoulder. So
I'm just like passing you. Thanks. For those people who are maybe interested in a commercial solution, we actually do have a product for that. It's the only thing that we can, I think, that's worth being called a product. And we've built basically a set of tools, a set of VIs that take over all the work that needs doing, like running the analyzer, setting up the repository, maybe cloning other repositories, creating documentation. So these things are wrapped inside the tools. And we've built the tool set in a way that we can have the configuration for them in the repository in a way that's rather straightforward. But of course, it still involves a little bit of knowledge about the specific tool that you're running. I think that many of those tools are similar to configure. If you look at the GitLab Runner versus the Azure Agent and even the GitHub Actions now, they are quite similar. Jenkins, which is, I think, a separate beast, in my opinion, is a little bit trickier to configure. But still, the idea is the same. So if you want to do it by yourselves, I think there is no way around getting familiar with the technology, with the terminology, understanding what a pipeline is. Setting up the tools, once you've crossed the first, but then the first step is not so difficult. And again, this will be the last advertising for today. If you're looking for support with that or for a tool set, there are things out there. But also there are more and more open source offerings. Like Sam mentioned, James, I think, published a handful of tools that build on the GCLI, so LabVIEW wrappers that can execute stuff. And if you want to go to the dark side, you can always use the LabVIEW CLI that has built in some things already. So depending on your specific use case, that might or might not be the right fit for you.
Hi. How do you upgrade legacy systems that currently do not support CI/CD? How do you start?
Which system? Can you describe your system or a system that would be one of these legacy systems?
It's just an old system.
Like a LabVIEW application? Okay. And is it in source code control of some form?
No.
Okay, so I think that would be probably the very, very first starting point would be to get the code into source code control system of some kind. And Bitbucket is a good one, and they offer SVN. Is that true still, or are they exclusively Git now?
that's your question.
Yeah, I believe exclusively Git now, or if not, it's being end of life.
And I'm asking because SVN tends to have a little bit lighter weight, simpler model for source code control. But yeah, a first step would generally be getting your code into source code control. However, if the code, some folks, the tools you have available, if the code's in a folder, if you have, backups somewhere, I'd say the very first step in continuous integration is to create a VI that has, when you run it, you feed it the path to your project, LabVIEW project file. And then there's some functions that can programmatically execute a build specification. So you can pass in the name of your executable build spec, and it'll do the build programmatically. And so I'd say that that's the very first step. And then that way, when you hit the run button, it does a build. You don't have to open the project, and you can, use Windows Task Scheduler. A next step might be to then read from the project file, the version. And then there's another VI in the LabVIEW palettes for setting the version of a build spec in a project. So then what you could do is you could, in an INI file, you could use the config file VIs to read the version from an INI file or automatically increment it. And you start creating your own VI which is your build VI. And you start to try to do programmatically all the things that you would normally do manually when you open a project, edit the build number, save it, close it, hit build. Try to automate that stuff. And that's really, I think, like the real first step.
Jim hits on a good point, and I work with lots of clients who are in that same situation. And the first thing is to get it into source code control. And Jim mentioned having all the backups and stuff. Make sure nothing's cross-linked, right? Make sure you can get a repeatable build and make sure it's versioned and like do things like add the version number to the executable in some visible place so you can make sure that you're running exactly what you think you are. Because all this continuous integration stuff, you got to build on a good foundation. The foundation is using source code control and having very tight versioning of what you're building and making sure you know what you're building. And then you just start automating the small steps. And don't do everything at once. Like Jim said, just start with the simplest thing, which is the build. And then once you get the build done, then you can automate the running the unit test. You can automate VI analyzer. You can start adding features. But the first step is kind of that like whole hello world of getting the build running locally in a script that you can call, ideally from the command line at some point. And then once you get that, then add the GitLab part of it, add the remote runner, run it on there, and then start building from there.
And does anybody know where in the palettes those are? Mm-hmm. Go ahead.
To get back and ask first a question, when you say you want to migrate an old project to continuous integration, what does that mean for you? What do you want to get out of it? Because we talk now about automating fields and things like this, but the first question would be, when you say continuous integration, what do you want? Do you want the EXE? Do you want the tests to run? Or what is it that you're after? So I think that would be the first thing to figure out, and then you can take from that, maybe make a decision on which source code control system to use, which tools to use, because the things that you actually wanted to achieve might make a difference in which tools you pick for that.
I'm wondering also too, is one of the challenges, yeah.
Maybe Git would be an easier choice, because if you go with GitHub or GitLab, they have the built-in CI machinery, which makes it simple to set up in my experience. So that might be easier than going with Bitbucket and Jenkins, for example.
Oh. I was going to say also, though, when you talk about a project like that that's not in source code control, one of the other benefits you get is being able to collaborate with other people, which also leads to the GitLab and GitHub stuff of having that central repository and being able to collaborate. Because with a single file or a single folder, right, that's not in source code control, collaboration is really hard, I would imagine. I mean, maybe you're not in a situation where you have other people, but that's always worth thinking about because you might be in a situation where you have other people at some point.
Yep, so we've done that first step. We've got a little LabVIEW VI, for want of a better expression, that automates our build specification, increments the build number perhaps, and now we're thinking about the other steps that we might want to perform. Again, we've got this VI as a starting point, and we want to then add to its functionality. So the next thing we might want to do is to automate VI Analyzer. So what do we want to analyze? What tests do we want to perform? What level of code do we actually want to run VI Analyzer against? Do we want to test everything? Do we only want to test changed code? So again, it's taking that small step. It's looking at the VI Analyzer tests that are available to you from National Instruments. I think there's like 130.
Way more than you need.
Way more than you need, way more than's probably useful in the beginning. But actually look at those tests and work out which ones are important to me. Also, work out what's the frequency. We're still talking about a manual process of running a VI. So what is the correct frequency? And you get into this situation of what I'd refer to as scenario-based testing. So I'm maybe going to run 50 tests daily or on every commit. I'm maybe going to run 130 overnight where time's not so much of a premium and work out which tests are important. Yep. But we're still doing it as a manual process from our VI.
Yeah, I would say you can get really, really fancy with all the scheduling and everything else. And my advice is it's good to have that manual process and know what you're doing. But I think for the automation part, just biting off tiny little chunks. So like maybe you start with just every time I push, I immediately run the VI Analyzer test. And you're still doing the other stuff manually, and then you slowly start adding it one at a time.
Yes, a good point. So, often we see people who they do the pipeline and they haven't really thought about which tests they want to run, and they get the first build output and they've got their executable, and then they look at the list of tests and it's huge. And that really appears as noise to you as a developer. And it can be daunting. And it's where a lot of people actually stop using CI because they see everything failed. Where is this adding value?
Yeah, VI Analyzer in particular is notorious for that because it can get very nitpicky. I'm sure I see some heads nodding, so I'm sure anybody who's used that has experienced that.
Getting over that initial hump too, biting off stuff that's small. The continuous integration, I think, really means that you always know if things are running or broken. And because this is happening continuously, and with source code control, you have every change tracked, it's possible then to, directly pinpoint why something's broken. You push a file, a test fails, or the build breaks, or it doesn't deploy. And so it's also important when you're getting started to not have too many problems, too many failures. And so, what I tend to try to do is, if I'm starting a new project, get the automated build working on day one, get a folder where I'm going to put my tests, and, start putting pieces there kind of incrementally as it adds value. But yeah, don't try to take on too much at the beginning.
When you start a new project, so not so much for your existing project case, but for new projects, I always try to just do a simple hello world project and get it to build right away on my local machine, and then I immediately get it to build on the server. Because once you have the building blocks in place and once you have all the automation connected, adding new steps to the automation is easy, right? So if you have the build working, then it's just a minor thing to add a line to say, hey, run the test.
And it's easy because you know why it failed when it stops working. Mm-hmm. The hard part is if you wait 2 months to set up your automated build and then all of a sudden it's not working. Well, you've got 2 months worth of changes and code to sift through to figure out why.
To add to Jim's things, debugging can be hard. So you want to think about when you're setting this up, how you're going to debug. Like your runner, you want to make sure that you have like RDP or VNC access to it. And you want to make sure that you're running stuff. There are different ways to run it. You want to run it so you can see the GUI and you can see what's going on. Jim has a good post on that on his blog. And I have one on mine as well about how to do that. The other thing that's really important is thinking about and managing dependencies. So Jim's company, JKI, has a great tool called VIPM. If you're not using it, you probably should be. And now with the new version of LabVIEW, right, you can make VIPC files for free, right? Isn't that included? Or it's in the next version or something?
Yeah, that's coming.
Yeah, it's coming.
It is now.
Okay, yeah, I don't know if it's here now or not, but
it's on Sam. Sam's getting this round. No, I'm just kidding.
Oh. But yeah, VIPC files are really huge. So it scans your project. It tells you what VIPM packages you have installed. And there's a tool. I have one. It's on vipm.io. I just put it out recently. If you search for it, I think it's called VIPC Applier. And it'll apply the VIPC and make sure everything's installed on your machine. So that really helps. Other thought process, actually, here's a question for you guys. Build machines. Do you put multiple versions of LabVIEW on a build machine? Do you have one build machine for each version of LabVIEW? Do you have one per project? Let's go.
One build machine or VM per LabVIEW version is how we do it.
Yeah, I sometimes do that, but sometimes I need different ones for different projects depending on driver versions, but curious to hear others.
Typically, it's one version per build machine. Lately, I've started to also install 32 and 64-bit side by side on the same machine so that I can essentially build, like if I'm building PPLs, I can build the 32-bit and the 64-bit PPLs on the same machine, essentially with the same kind of checkout job.
Same as James said, basically. One virtual machine per LabVIEW version, both 32 and 64-bit, for the same reason actually. It's just more convenient for the PPL stuff. And yeah, we're running the vSphere and ESXi server, so VMware virtualization thing that hosts our virtual machines in the office. Most of our customers also use virtual machines. I think only one or two actually have physical machines, still have field machines. Most of the bigger companies have an easier time ordering virtual machines from their IT than putting a physical machine somewhere.
Do you have a question?
Yeah, questions.
Yeah. I just had a question overall, if you're trying to go into this process, is there any incorporation of manually testing anymore? Or does everything have to have a unit test or some automated test? And if that's the case, do you have to go to like a test-driven design where you're writing your unit test for everything? So right now we're doing a lot of manual testing and you're adding new features and you have to plan that all out so this will actually work.
So GitLab, I don't know about the other ones, but you can have a manual step that when it gets that step in the pipeline, it just stops and it waits for you to press a button. And so that's your chance to then download whatever's been done so far and go test it and make sure it works. And I would highly suggest doing that because you're still like getting a step closer to automating, right? So, and it's giving you that reminder that you have to do that in order to continue, so.
Yeah, I'd kind of almost take a step back there. If you're not doing CI right now and that's what you're already thinking about, maybe there's an intermediate step, which is to create the VI that Jim mentioned earlier that's doing the build, running the VI analyzer test, running the unit tests, and then maybe incorporate that into some hooks within your source code control. So within Git, there's a feature called Git hooks that allows you to script certain activities when certain actions occur, such as a commit. So on commit, I'm going to run my top 5 favorite VI analyzer tests, run the unit tests, maybe produce a build. It kind of incrementally takes you through that process.
And Chris, does that happen on the developer's machine locally or in the cloud?
It happens on the developer's machine locally. But I think it's a good stepping stone, actually, from nothing to full-blown CI in the cloud on a DevOps instance, for example.
I think Git hooks are an underrated feature. I think they are very useful. They're very useful for all kinds of things. Like I use it to like make sure I include issue numbers in my commit notes and things like that. You can use it to run your unit tests. So depending on how you have everything set up, I tend to do a lot of chunk-based development. So what I don't want to do is push my stuff to the server and have it fail when I could catch that locally. So I often run the unit tests locally before I push. If you're in your own separate branch, it might not be as big a deal. But generally, like one of the things is if you have a CI/CD pipeline, whatever your main or trunk or develop or whatever, like if that's broken, that needs to be like a priority immediately to fix it. Because if it's broken and 5 people check it out, while it's broken, all 5 of them will fix it in a different way, and then they'll all go try to check it back in, and you'll end up with a giant merge conflict, and it's a huge pain. So it needs to be one of those things where, like, when it fails on the server, particularly on your main or trunk branch, you want to fix it immediately. If you're in your own branch, maybe not a big deal, depending on your workflow, but...
I think that's a great comment as well about the, when you make a commit, you don't want the code to actually hit your repository. You want to check certain basic things like, you didn't call the thing untitled1.vi, that it has a non-default icon, for example. There was a great phrase by Joel Spolsky that said, bad code that gets committed tends to stay committed, i.e. it's just harder to go in then and fix it, and the motivation's not there. So if you can reject the commit because you've made some basic error, if you can reject that locally, that can be useful.
So I want to add to that we have been having hard times rolling out Git hooks because they are really a local thing that you need to install and seems manually on each machine. So we haven't found a good way to roll it out through source code control.
VI package.
So that was a bit of a pain. And I want to say a second thing, but Sam, I think they have a response to that.
Yes, actually, I was going to say, what I do is I have a directory in my repository called hooks, and I have a little script that's set up Git hooks, and you just run it as soon as you clone it. It is a manual step, though, so you do have to remember to do that. So I know Chris was saying you could do it with a VI package, which I could totally see doing that, too. That hadn't occurred to me. But
tricky to install the stuff into the repo would work best. So if you do a VI package, you can install it into the assembly location, but then still in your repository you need a configuration. But anyhow, I was just wanting to say that it was tricky for us to roll it out. And the other thing that I wanted to say to the gentleman who asked the question initially about testing stuff, I will put myself out there now and say that we don't do a lot of unit testing. There, I said it. For much of our work that we do, it's a project business that is, first of all, one-off. So we don't even know if we get to go back to touch the code again that we create. So there is not much value at that point in time in creating unit tests. Of course, when you have to go back and then change stuff, you wish you had them already, but that's a business decision to make. So there's some middle ground in that. So I do think that even having a CI system, a pipeline, and I'm like a huge proponent of CI/CD, of course, there's still a lot of room for manual testing. There are some things that you cannot test on your source code alone. I mean, not everything is a software. Some things still are integration tests, regression tests, whatever you want to call them. And at some point, the unit tests become so complex that it becomes more work to maintain them and to actually do some steps still in the manual way. So I think, in my opinion, the answer is yes, there is still room for manual testing, of course.
Another question.
So back on the dependency question, so we do use the VIPM API in order to auto-load a VIPC, but we do notice too that that doesn't catch, let's say, LabVIEW or NI specific maybe toolkits that were installed as part of the normal install process. How do you grab those dependencies?
So one thing so Christian Butcher, who I don't know if any of you guys know him, but he had this idea, and he's got it working, I haven't tried it, of just creating a blank NI package that does nothing, but depends on all the things that you need, and then you can install that. And you could probably figure out, there's a way to automate NIPM from the command line and install stuff, so I imagine you could do that in an automated fashion.
That's a great suggestion. Yeah.
So we're dangerously close to releasing a new version of Dragon that has LabVIEW project environment integration and allows you to manage a list of both VI packages and or NI packages in text, clear plain text file format.
So that would be similar to like the Python requirements file or something.
Yeah, exactly. It would be similar to like a Python requirements or like a cargo.toml file.
And also, NI package manager has a CLI lines, we can automate that as well. So the idea that Sam mentioned, having an all-encompassing NI package that you can then apply automatically, silently even, if you want to do that. It's basically the same, I guess, as applying the IPC file, just that you go through NI package manager. It's still a question of catching all the things that you need. So of course, you have to be aware of the dependencies, and sometimes I guess they might be tricky to install automatically. Well, so that's probably where you might want to look into separate virtual machines or separate build servers for different installation scenarios. It's really tricky. At some point, the automation becomes more effort than it's worth, and you just have static machine.
Can I add one more thing? Yeah. So one of the features that is in this new version of Dragon is the ability to sort of scan your project files in a convenient, quick way, and identify which NI packages like NIScope, DecMX you depend upon, and then to have those in there as well. Or even, LabVIEW Core x86 2023, and then to, compare that. And then the thing too is if you have your build server set up, one of the nice things about using, like, for example, Docker is it's often a good idea to actually test an automated bring up of a vanilla installation. Vanilla, I mean, like, it doesn't have anything other than maybe NI package manager installed, and install that set of software and drivers, and then, pull your project down and try to build it to make sure that you're not forgetting about some little driver component. Because even if your build server has all those necessary components on it, the build server that you hand bootstrapped up, when that machine dies 10 years from now, then somebody has to get the build working again. but then that person might not necessarily, know that that was a missing key component of the system, and the build will start failing, or it just will be different than what you had been shipping for 10 years.
Yeah, Jim brings up some interesting point. Another thought process too is the NIPM package stuff. Like, yes, you could probably install it as part of your normal CI/CD pipeline, but I think there's an argument for having the pre-built machine. And even if you do what Jim does, you could have the vanilla LabVIEW install the packages for your project and then save that as its own separate Docker container, so you're not installing it every time, because some of the installs take a while. So for me, like, a big thing is getting fast feedback. And so doing tasks that take forever, like VI Analyzer and some of the other ones, that's like a non-starter. I want my pipeline to finish in like 10 minutes.
And Docker is nice because the images can be essentially kind of cascaded. And so one can have a configuration for a base Windows install and with NI Package Manager version 20.0 and then, LabVIEW version whatever. And then if you're actually kind of cascading those Docker images, then when you change a configuration, it will only rebuild, assuming you have those images cached locally, it will only rebuild the ones downstream from that change. And you can also, set up a container registry locally or in your organization to keep those images close by so that they're easy to get.
So we've been talking a lot about LabVIEW as well, but I'm sure there's probably people in the room that are test end users. And it goes without saying that we might also want to incorporate test end into our CI/CD process. Fortunately, test end does come with a helper tool, buildtsd.executable, which has a command line interface to allow us to automate our test stand builds. In terms of the dependencies, one little tip that I recommend is to actually, the LabVIEW libraries that you are calling from test stand, I recommend that before you do the test stand deployment, similar to what we talked about with running a build specification, I would run a build specification that produces a source distribution and then create a PPL out of that source distribution so that it pulls in any OpenG, any GPower, any external libraries that you might be using, pull those in. It's one way of managing the dependencies from a test stand perspective. Jorg, anything? Hello, Europe.
No, nothing from myself. You said it all, Chris.
So I have a question. How do you manage the outputs of all of your CI build steps? Like, where do you guys store them? How do you handle that? And how do you handle like promoting stuff from like having a beta release to having a stable release, things like that? Do you guys do anything like that?
So a couple of things. I've used tools like Artifactory to take the build artifacts and actually make those available externally. But it can be as simple as having a script within your CI pipeline that uploads something to an FTP site. That tends to be a common, easy achievable solution.
A lot of people use different branches too. So you can have a branch for, production release code. And then, you can essentially kind of merge or do pull requests into different branches as a way of promoting. And then the CI steps can actually look at what branch they're building from and do different actions depending on the branch. So that's a good way of kind of segmenting.
Yeah, if you're into the Git flow stuff, I'm looking at you, Jorg. You can do different stuff like right before you merge into main and things like that, or kind of schedule things so you're not running everything all at once.
Sorry, Sam.
No, that was my last comment.
Go-to mechanism is to copy the build results to a file location. In our case, it's a network location, our network storage system. So the tools will build whatever's being built, the exe or the source distribution, or even the VI package, and zip it up. And then we'll copy it to a specific location. And then we have a wiki, like a web-based wiki system that we're using for most of our documentation stuff, and that has a plugin that will tap into GitLab, into the GitLab API, and get all the release tags, and then we'll look on the network system to see if there are certain files in specific directories and create download links. So that is quite convenient for us, quite comfortable in getting things that we want to publish to our customers. The second option is, I think, for VI packages to upload them to candidlyabout. And I guess at some point in the future, there might be even an API for that. Jim? potentially.
That's correct.
Is it already possible? I don't know. I think it's not yet there.
No, but the mechanism, it has a web interface that's very, very simple to upload.
And the third option that we currently use with our customers is to upload packages to the system link server. So obviously that's also a big thing in the NI ecosystem to tap into system link and to upload the NI packages that we built so that via system link they can be then further distributed. But that's only for one customer at the moment. Most of our customers use the cloud-based, put stuff somewhere where we can find it, and then something happens to that.
Yeah, I will just comment, if you're using GitLab and you're using the public server, it has its own built-in release system and it will store those things for you. So if anyone wants to figure out how to use that.
Often, right?
So normally in GitLab, when you run a job and it builds something, it only stores the build artifacts. It stores them for some amount of time, but you can create a release, which is a separate thing, and it will store indefinitely. At least that's what I've been told. So I've got my fingers crossed on that one. But I would back all that stuff up too if you're doing stuff on things like GitLab.com. It's just good to have it. We have time.
I'm not sure.
A question here. We were using Jenkins, and I think it's been mentioned a few times. We are slowly migrating to TeamCity, but we are using that to currently build our C# code. Any experience with TeamCity? Is it very similar to integrating it with LabVIEW? And the next question is, how do you guys deal with LabVIEW licensing? Does LabVIEW licensing allow you to install on a build machine, a personal license? Or do you need a separate license for that? We never got an answer from NI in regards to that.
Jim might know this
I think
better.
if you didn't get an answer from NI, then it sounds like you're not doing anything wrong. So I know when we activate ours on Docker, it works. But there's so many different flavors of licenses, so your mileage may vary.
From what I know is you can get basically a free version for your CI server if you own a valid LabVIEW license. I'm not sure about the numbers though, how many CI licenses you can get of how many proper LabVIEW licenses. But there's definitely a thing that has come recently from NI in terms of licensing LabVIEW for your build machines. As for TeamCity, I'm sorry, I have no experience with that. I can't talk to that.
I've heard of it. I know people who've used it, but I don't know anything about TeamCity. But to the licensing thing, to Jim's point, if it works, I would just assume that if you're doing something wrong, they'll let you know.
There are ways to activate LabVIEW via the command line as well. And so that's the mechanism we use when spinning up like Docker containers.
I do know NI for a while was selling a CI license for like $300, but I thought that had gone away. And I thought there was some changing to the licensing that now allows you to put it on a CI server with your normal license. So,
Thank you.
So I guess the description of this whole meeting said we're talking about the ROI and then also how to get started and potential pitfalls. Have you covered all of that? What about potential pitfalls? I guess that would be interesting to get from all of this.
yes, I think we should get into that in 1 minute, but I think we have a question first.
Yeah, so
We can hear you.
so you build executable, right? And then you release to the production. We have probably many productions, right?
Mm-hmm.
And then we have source control place like actual lab. We have that, right? But we build it and then we release that executable to all these different machines. But there's no version. And then 10 years later, we do not know which production is executable related to this source code. And we use accurate have this version. But sometimes we have this new version that may not be the release in production. How do you manage that?
So I think the first step is when you create a release in Git, it should be tagged in Git That's right. So
So my question, how do you tag it? Do you like for now, I just manually write something when I have field, I manually write something on this field for whatever.
so there,
It's on the GUI, like RC, this kind of RC001.
What you can do, so the approach that we typically take is with the G command line interface, GCLI, you can pass command line arguments to the build. And so what we've done in the past is have our CI script knows which branch it's being built from or what tag. That information can get passed into LabVIEW via the command line, or other mechanisms. You could write it to a file from when you're configuring your YAML, like a script could write that information to a little file that gets read by your build VI. And you could then programmatically set a front panel control default value. And that could then be read programmatically inside of your application to tell exactly which Git revision or branch or tag it was from. And so that would then live with your executable. And you can also programmatically set the version number of your executable so that that's displayed as well. And then when you're doing your releases, you can also, take what's called a hash, like an MD5 or SHA-256. It's a number, it's the signature of the binary file. So you can tell if the file that's running on your test system is the same one that was released because you made a record of that signature of that released file when you did the official build.
But that's not it. What is your list? Your source code repository? Because we use Apple. I don't know.
I don't know that one.
Yeah. So which one did you use?
We use Git.
Git. So that has these methods to allow a version displayed on the GUI.
well, I think whatever version control system you're using has a unique way to identify a specific commit or the Git terminology is commit, but a specific set of source files, right? And whatever that is, to Jim's point, you could include that somehow in your execute. So when you run your build and you have your VI or whatever that does your automatic build, somehow you pass it that tag, right? And I use the word tag, but it's just the revision number, right? It could be as simple as that. And you display that somewhere for the user, and then they can say, hey, this number somehow ties back to your source code control system. Does that make sense?
Yeah.
I think we're out of time.
And I guess we're out of time, I've been told. Does it sound about right? Or do you have a minute? Or are we done?
5-minute warning.
We got 5-minute warning. Okay, well, you're going to talk about pitfalls. What pitfalls does anybody out there run into? Hunter.
I'll do a bunch of work to set up a CI system. It's beautiful. All the tests are passing. We hand it to a customer. It falls into disrepair. How do you fight entropy in a test system that it seems like you're constantly having to put effort to maintain it? But yeah, even when you do the work and it's all automated and set up, a lot of times customers won't put in the effort to fix their tests.
I think you have not clearly communicated the value of the testing, right? So I think the first part is be clear for yourself what the value is, and then figure out how to sell that and tie that to something that they actually care about.
Well,
Easier said than done.
You can also just break the build, and then that individual is accountable for a broken build. And then organizationally within the group, there's a decision that has to be made. Is having a broken build for 5 days when so-and-so who doesn't like to write unit tests, are we willing to make that trade-off? Or are we going to assign somebody the job of cleaning that up and making sure that everything is working? Because, a test engineer cares about testing their end product, not necessarily in writing unit tests for software.
Yeah, but I do think that is good. Yeah, if you actually care about it, it should break the build, because that forces them to see the pain, right? Because if you just run the unit tests and the unit tests fail, but it doesn't break your build, then it allows them to keep going. And my guess is that the people who are doing this and not writing the unit tests are probably not smart enough to figure out how to flip the switch so the tests don't break the build.
Or they just have more important things to do.
And also, really, when you hand that over, part of the process should be that even if the unit tests are passing, if there's been significant churn on the code, they should be revisiting those unit tests because they may be stale and not actually capturing something that is needed. Yeah, code coverage.
Yeah, I think it goes back to there needs to be an agreement in the team as to how you want to use leverage CI. So you have to have buy-in from everybody and understanding of what it is that we want to do, and that we decide to, for example, run unit tests and not ship something when unit tests are broken. So I think there needs to be the agreement first, and not only the system, like you said, we have situations where the system is A+ running, but people are using the process, not like doing the right actions in Git to actually trigger the system, just working around it. So it starts with the people to buy in from the team.
Yeah, I think team agreements are huge and have them make the team agreements. And then if you find that they're constantly breaking that, then figure out and go back and be like, okay, here's the value I see in this. You guys don't see value in it. What do you suggest that we do instead? And then change the process. And maybe the process is we don't use unit tests. And you know, to us, that sounds horrible, but maybe that works for them and they're happy with that. And ultimately, if they're the customer, then they're happy, then okay, who are we to say that you should go do this other crazy thing? I mean, you can't force people to do things that they don't want to do. So if they don't see the value in it, you know, who are they doing it for?
But sometimes they're just not far along yet. Maybe in 1 year or 2 years' time, they have like tidied up everything, and they're at the point as a team where they understand and can benefit from things that you get from unit tests. But if you're just starting out, maybe it's just too much because they're still struggling with the style tags, for example, or whatever. So it's a journey.
Yeah, you definitely want to start with the basics. And like for this whole discussion, if it wasn't obvious from the very beginning, the very basics is source code control, tight versioning, make sure that you know, to the point of the lady down there, like make sure you know what's running on your machine and make sure you can tie it back to your source code control. If you can't do that, all this other stuff that we're talking about is all fluff. It doesn't mean anything.
All right, any other situations anyone want to bring up?
I think we have one last question.
I have a question with the Git and the PPL. So there's a scenario. So I know you guys tell that you want to put the PPL outside the Git repository. That's what you were saying before. So
Not checking PPLs into Git.
yeah. So I mean I searched online. There's video called 9 times we manage the PPL, just put on maybe like CDs or something like that, right? And when you build a PPL, some PPL you just it's a parent classes, right? You need to use as inside the other project and as the parent classes. You are replace the class with that PPL to inherit it by that. And some of the PPL classes, the library is just the children, the specific class. Right? For the specific class, you can dynamically to launch it. But for the parent side, you will not you need to put into the dependency, right? So I have the question is when we doing I tried a lot of time. If I didn't put that parent PPL to replace our original file and then to build that, and our final sometimes I will have error from the NI builder. Sometimes I will have maybe like the dependency issue with the PPL file for our next project. I just want to know the official way how we manage the PPL with the Git.
Well, I think you're on the right track because building PPLs is a pain and you got to do everything right. And to Jim's point earlier, there's a lot of little steps that you got to get right. So automate is totally the way you want to go. You do want to automate that process. Maybe these guys have more tips on how to do that.
I think we're out of time.
Yeah, I would seek out, there's a presentation by Michael Lacasse on PPLs. I would urge you to seek that out. That's got some good tips on doing just what you've described.
So sorry. So
come see me, and I'll write that down for you.
Thank you.
Thanks, Chris.
All right, thanks, you guys.
If you can get away without using details, that's probably the best way. That's
All right, thank you, panelists.